Morning, everyone. Can you hear me?
Yeah, sure.
Yes, teacher.
Okay. Okay, we'll just wait for a couple more minutes because Mehak is having difficulty trying to come in. Um, and then we will start.
Sorry, Ms. Sharina, for the delay.
It's okay. All okay now?
Yes, teacher.
Okay, good morning everyone. So I posted this paper and I told y'all to do selected questions. So let's go through this. Has everyone done it?
Yes.
Yes, teacher.
Okay, let's go through this. So this is a past year paper, paper 4, variant 1, May, June 2018. Okay, paper 4 is usually 1 hour, 15 minutes. And there is roughly about, this case, it has about 11 questions, yeah. On average, 11 questions for paper 4. Okay, so not all of this you all have studied yet, which is why I only told you all to do selected questions. So we'll go through it. Yeah, we'll go through the answers, yeah. Okay, let's look at question 1. Everyone can see my screen, huh?
Yes,
Yes.
teacher.
Yes, sir.
So I have a speed time graph for a vehicle accelerating from rest. So from 0, it's starting to accelerate. So what's the acceleration of the vehicle at time 30?
Oh,
At time 30, what's the acceleration?
15, teacher. I wrote 15.
15. This is a speed time graph, huh? So
Yeah.
and I have,
What am I saying?
how do I find acceleration?
total speed over total timer.
Yes, so I have to divide. So basically, I'm just finding the gradient, or yeah, I'm just finding the gradient. So speed over time. So I have my graph there. Yeah, let me just draw the graph on the whiteboard, and then I'll switch to whiteboard. Okay, so it says there time 30. Okay. The time is what? 30, yeah. Just a minute. 20. Okay, I'm just gonna switch to my to the whiteboard. Okay. Can you all see?
Yes,
Yes,
sir.
teacher.
Really or not?
Yeah.
Yeah? Okay,
Yes.
so basically it says at time 30. So at time 30 means, they're asking what is the acceleration, and just now Rohindra said acceleration is speed
Total
over time. Total speed over total time. So at time 30, 30 is somewhere here between 20 and 40. What you want to do is you want to go up and then see what the speed is. Okay, so look at the graph. At 30, what is the speed?
15.
This one I simply draw, it's not according to scale. So you'll have to look at the graph to properly know. What is the speed at 30 seconds?
Uh,
15? Yeah, I think it's about 15 or so. So I take my speed divided by time. So 15 over 30, which is, what is 15 over 30?
0.5.
0.5. Okay, so that will be your acceleration. Okay, let me see. Let me look at the question again. So 30 is somewhere here. Oh, it's slightly less than 15 lah. Maybe 11, 12, 13, 14, about 14.5. Okay, if I use in here, about here.
But it's still 15 what?
Is it? I don't know. Let me see.
Yeah, it's still 15.
Okay lah. Then okay lah. Okay. So it will
Okay.
0.5 meter per second per second.
Okay.
Okay, let's go to the next one. Without further calculation, state how the acceleration at time 100, so in 100 seconds, compares to acceleration at 10 seconds. Suggest in terms of force a reason why any change has taken place. So if we look back at the graph, okay, 10 seconds is here, okay, somewhere here. And then 100 seconds is somewhere here. Okay, what do you think the acceleration will look like? Acceleration means being speed divide time. Without calculating, just by looking at the graph, what can you see?
At 10 seconds, the speed is above 5.
Okay,
And 100 is... I can scroll down a bit. 100 is around 29, something like that.
okay. But that's the speed. We're talking about acceleration.
Acceleration increases.
Increases? Now, between at 10 seconds and 100 seconds, where is the graph steeper?
And
120.
No, not 100.
10.
10. You see, at steeper meaning, right? If let's say you go up a staircase, right? If a staircase is steep, means it's like it's not wide enough. So when you walk up, you feel like you're falling. That's called steep. Okay. Whereas if it's not steep, then you go up like normal, like our normal staircases. Okay. So if you look at 100, the graph here. Okay. Let me just take out the pen. Okay. The graph here is much more flatter, in other words. Compared to here, it's a leap. Okay, here it's a bit flatter. So when the graph is steep, the acceleration, we say that the acceleration or whatever quantity of the gradient, we say it is, the rate is fast. When it is a bit flat, that means it's not increasing as much compared to this. Okay, again, I show you. So let's say 10 is somewhere here. Okay, you see, it increases. When I take my acceleration, when I take my speed over time, there's a jump. Correct to when it is 100 seconds, which is here. From the previous to here is not a big jump, it's flatter. So that means the acceleration here is a slower rate or faster rate?
Lower rate.
Slower rate.
Slower.
Here it's not increasing as fast. Not that there's no acceleration, it's just that it is not increasing as fast as compared to here. So we say at 100 seconds, okay, so okay, at 100 seconds, the acceleration is at a faster rate compared to at 10 seconds. Okay, so we say acceleration is at a faster rate. Slower rate at 100. 10 is faster, sorry. So at 100 seconds, acceleration is slower, at a slower rate.
Okay, sure.
Okay. Now, then it also says, suggest in terms of a force, a reason why any change has taken place. So in terms of force, why do you think the acceleration is slower? This is a vehicle. So what causes the acceleration to be slower in terms of force? What do you think is present?
There is more friction.
Friction.
Correct? So you can say there's more friction or there's more air resistance. Okay, or you can also say the driving force, the vehicle is moving slower. That means the driving force itself is slower. Also, you can say that. Okay, and then now when acceleration is less, okay, then there's more friction, there's more external forces. Is the resultant force big or small?
Less.
Less.
C.
Small.
So you want to say that the resultant force is less.
Yes.
Okay, and then the next one. They're asking to find, what are they asking to find? Yeah. The next question.
Area under the graph.
Correct. So they're asking for, they're asking for distance traveled by the vehicle between 120 seconds and 160 seconds. So if you see, it will be, when I have a speed time graph, it will be area under the graph. So you have to look for this area here. So this is a straight line. Okay.
Yes.
What shape is this?
Trapezium.
Trapezium. So how to calculate area of trapezium?
Half A plus B divided by 2. C. A plus B times H.
Yep. So half times the sum of parallel sides. So this length plus this length, you add them. Let's say this is A and this is B. And then times with the
Height.
height. In this case, what is the height?
Down there.
160 minus 120?
40.
40.
140. 40, sorry.
40 lah.
So to calculate this
I said 40 after that, okay.
this length. Okay, what is the length of the parallel sides? The sum of the parallel sides. Let me go back to the paper.
40 times 20.
Okay. So
Huh?
this is, what is the length here?
Thir-
30.
The length,
T.
that's 30 speed.
30.
Here?
20,
20.
So 30 plus 20?
50.
50,
50. 50. So half times 50 times 40.
Half times 50 times 40.
1,000
1,000.
meter. So your distance is
1,000.
1000.
1,000 meter.
1000.
Yes.
When I did the graph, area under the graph, I separate the triangle and the rectangle.
You separate the what?
The triangle and the
Okay.
rectangle.
So
Then I
like,
cross them together.
so like this. Can also.
Okay. Okay.
So you can do triangle or this. Because in this case it's a trapezium and this one is a slant. It's a straight line. If it's a curve, then you have to, then it's a different story. But because this is a straight line, you take it as a trapezium also okay. You want to divide into two shapes also okay. Okay? All okay so far?
Yes.
Yes.
We'll go back to the okay.
Number 3.
Okay, Wingyan, okay?
Yes, sir.
Beatrice, okay?
Yes, sir.
Nicholas?
Yeah, sure.
Mahek? Mahek, okay? No answer. Lohindra and Tachu?
Yes, sir.
Okay, let's look at number 3. So the next question that I told you all to do is question 3. So I have a rectangular container, a base of dimension 0.12 and 0.16. Container filled with liquid. The mass of the liquid is 4.8. Calculate the weight of the liquid in the container. What is the weight? So it has a mass of 4.8, but what is the weight?
4.8 times 10.
Right. So when I have a mass To find the weight, I just times 10 lah. Why do I times 10? Why is it 10?
Then value. Then value. I don't know.
I can't hear you, Darshan. Louder.
Okay, teacher.
I can't hear you.
Never say anything.
Sir, she said Newton value.
Okay, so there's a reason why we times 10. So the reason why is because, okay, so mass is in kg. What causes weight of an object? Okay, weight is acting towards what direction?
Down.
Down. What is another force that is acting downwards?
Gravity.
Gravity. So gravity is the one that causes weight, which is why if you're on Earth, your weight is different. You go to Mars, your weight will be different because gravity is different there, but your mass will be the same. Your weight will be different, and gravitational acceleration is 10. That's why we times 10. Okay, actually it's 9.8 got decimal lah, but we round it off, we times 10. Okay, so 3a, calculate the weight, it is 4.8 times 10, which is 48 Newton. Okay, make sure you have your unit there. Okay, next, the pressure due to the liquid on the base of the container.
Also value.
Okay, so I have pressure equals to force over area. Okay, what is my area of the rectangular container? How do I find that?
0.12
Yeah,
times
0.12
0.16.
Correct. So that will give me my area of the base. Okay. So, and then what is my force? What is the force acting on the base of the container?
48 lah.
Yes, 48, because that is the weight of the water. So, 48 divided by 0.12 times 0.16. What do I get?
0.0192.
0.192.
0.19. Oh, you mean at the bottom?
0.0.
Oh, yes.
Okay. And then
500.
2500.
2500.
0 Newton meters square, or you can also write it as Pascal. Okay?
Okay.
Okay.
Okay. Let's go on to the next one. So that's the pressure. Explain why the total pressure on the base of the container is greater than the value calculated. So the calculated value is 2500, but the total pressure on the base of the container is greater than the calculated value. Why? Why? I already calculate what the what is that? The theoretical value. I have water here. Okay. I have water. And then I have the mass, the weight of the water, and so forth. And then I have the area of the box. But why is it that the actual pressure will be higher than the calculated pressure? Why?
Because there will be atmospheric pressure.
Because pressure from outside, atmospheric pressure. Okay? Atmospheric pressure is pressure from the air in the atmosphere. So atmospheric pressure will add to the pressure of the water. Okay?
Aye.
So because of atmospheric pressure, the actual pressure will be slightly higher.
Okay. Yes.
Teacher.
All okay so far?
Yes.
Yes.
Okay, then we look at the next one. So I have the depth of the liquid is 0.32. Okay, back to this. So I have the depth of the liquid is 0.32. So here. This here is 0.32. Calculate the density. What's the formula for density?
So volume.
Mass over volume.
Okay, so mass over volume. What is the mass of the water?
0.12 times 0.16.
4.8 kg. What is the volume? How to calculate volume?
0.12 times 0.16.
Okay, I was gonna say length. Okay, never mind. Thank you.
Then times 0.32.
0.32. Okay. So, what is the density?
781.
0.12 times 0.16.
781 kg.
781.25. Did you all get that?
Yes.
781.25 kg per meter cube. Okay, so density equals to mass over volume. So this is the density. Now there's another way to calculate density. Another way to calculate, density of the liquid, of the water. Can anyone tell me how? How do you calculate pressure in liquid? What is the formula for pressure in liquid?
I forgot.
Volume and does it have to do with volume and density answer?
It has to do with density.
Uh,
Just now we calculate pressure in terms of the pressure that the water exerts on the container. But pressure of, because we want to find density of liquid. Okay, density, this is symbol for density. Density of liquid. So what is the pressure for liquid? What's the formula?
Area over something.
No.
no.
I don't know.
When I have a liquid, when I have a container, and I have water.
Volume.
No. And then let's
Uh,
go right now.
Volume over height. Volume times height.
The height and density.
So I have
Height.
density times
Width times breadth. Oh,
P. P is what was that?
yeah. Gravity.
I can't see anything because like once someone starts talking, I can't see.
Then you pin the video lah.
Video.
I'm trying. I can't do it. I don't know why.
Okay,
You don't have to pin a video.
Is
So.
it H times P times G?
yes. H rho G. Okay, just pause for a while. Mehak, you go to my video.
Okay.
Go to the 3 dots at the top right.
Okay.
Click on that.
Okay.
Does it say pin video?
No.
No?
What does it say?
What do you see?
It says chat, raise hand, disconnect audio, and then show name when participants join.
Yeah.
Lol.
Yeah.
Why are you seeing all those?
And then hide non-video participants.
You don't have
I
Oh, how do you do that?
just not using laptop, that's why I don't have.
or you use
Oh,
Yeah.
yeah, I hide everyone already. Now can.
Oh, okay. Okay,
You
so
just wow.
for pressure in liquid is H rho G. H being the height, rho being the density, and G being the gravitational acceleration. So now,
We know that from the previous question, pressure is how much just now we calculated?
Pressure.
From the previous
The previous question was
2500 PE.
250.
yeah.
Now, what is the height of the liquid in this container?
0.32.
Yeah. Density is what we want to find. My gravitational acceleration is 10. So 2500 equals to 3.2 times density. So density is equals to 2500 divided by 3.2. And you will get the same answer. 781.25 kg per meter cube. In this case, it will be, this is P, and then this is Hg.
So why is it Hg?
Because height times gravitational acceleration.
Oh, okay.
But no, we don't put it this way. You can just put kg per meter cube. Pressure. This pressure is force over area. Force is my weight, Newton, over meter square. Just write it. Okay, you get the same answer. So this is another method to find the density of the liquid. Okay.
Okay.
All okay so far?
Yes, sir.
So,
Yes, sure. Okay, so that is for question number 3. Okay, let's look at question 4. Question 4 is not difficult. Okay. Describe the movement of the molecules in a solid.
Vibrates.
Yep, vibrates. In a gas?
Really move around.
Free
around freely.
Yeah,
Same thing,
all
yeah.
directions. Random.
Further apart.
It says movement, so you have to talk about how it moves. Okay, the keyword here is movement. Okay, a closed box contains gas molecules. Closed, here it says closed. Explain in terms of momentum how the molecules exert a pressure on the walls of the box. So in terms of momentum, how the molecules exert pressure on the walls of the box. So let me just highlight some keywords here. In terms of momentum, molecules exert pressure on the walls of the box. Okay, so talking in terms of molecules, the particles. Okay, who wants to try?
Yeah, they keep hitting the walls of the box, then they gain energy.
Okay,
Gain more energy, then the pressure be higher.
okay, so and then in terms of momentum,
There is change of momentum during collision. The molecule.
okay, so the first point, when Shaluk says, so it moves, it hits the wall. So the first point is molecules collide with the balls, with the walls. You must use the word collide. Okay, so first point is molecules collide with walls. Okay, this causes, so like he said just now, it gains energy, right? So when it gains energy, and it keeps hitting the wall, it hits, bounce back, hits, bounce back. So it gain energy, it hit, and then it lose energy, and then it gain energy, lose energy. So what happens is when they collide with the walls, there is a change in momentum because the speed changes. They gain energy and then they lose, not lose, like they transfer it to the other molecules. So the speed changes because they move slower or faster depending on the energy. So what happens is when molecules collide with the wall, point one, second one, there is a change of momentum. Okay, molecules collide with walls and this causes a change in momentum.
Okay.
Then we're talking about pressure. Okay, so how do we relate pressure to the momentum? Because when we answer, we want to make sure that each sentence, they connect with one another. So how do we relate pressure with momentum?
The more momentum, the higher the pressure.
Why? What? There's something that happens in between.
The molecules hit the walls and this causes pressure on the walls of the container.
Not quite. I mean, you're getting the idea, but okay, let's see. Okay, so the first one is, we say that molecules collide with the wall. Okay, molecules collide with wall. Okay, and then this causes the change in momentum. Now, when the molecules hit the wall, what happens? There is force. Okay, there is force on the wall. Okay, that force, okay, equals to the change in momentum for every second. Okay, that will produce the force. So when there's a change in momentum, this produces the force on the wall. It hits faster and then slower. So that causes the force on the wall. That's number 3. And because pressure is force over area, okay, when the force is applied on the wall, and the wall of this area, so the pressure is equal to the amount of force applied on the area of the wall. Can you understand?
Yes, teacher.
Yes, sir.
Okay, can I change back to the question? Anyone still copying?
Sure,
No,
I'm
sir.
done.
Still copying on my head.
No, sure, I'm done.
Okay, if anyone of y'all is still coughing, let me know. If not, I will change. Okay, so that's for question number 4. And then we jump to question 8, right?
Yes.
Yeah.
Okay, so I have a lab at room temperature 200 grams of water poured into a beaker, thermometer placed in the water, reading is 22 degrees. Okay, so what I tell my Isuka students, which I will also tell you is, now, paper 4 has 11 questions and there's 1 hour, 15 minutes. So there is, so 1 hour, 15 minutes is to altogether how many minutes?
60 plus 15.
75.
75.
60 plus 15. 75 minutes and there are 11 questions. So if I divide 11, each question, you can only allocate 6.8 minutes. Theoretically lah. Okay, so it's not a lot of time, but at the same time, it can be done. So what I tell my Isuka students to do is, when you read the question, okay, to save time, the first thing you do is, you underline the key values as you read. So for example, I have room temperature surrounding. Okay, and then I have my, just a second. I have 200 grams of water poured into a beaker. Thermometer placed has a reading of 22 degrees. And then I have small pieces of ice, 0 degrees, added to the water 1 by 1. The mixture is stirred after each addition until the ice melts. This process continues until the temperature recorded is 0 degrees. So from 22, it became 0 after adding ice 1 by 1. The total mass of ice added was found to be 60 grams. Okay, after the water became 0, then they realized that, okay, the amount of ice they had added to bring it to 0 degrees is 60 grams. So I have specific heat capacity of water being 4.2. Calculate the thermal energy lost by the water originally in the beaker. So, how do we do this? This is one of the first few topics that we learned in class, specific heat capacity and all that.
200 times 22 times 4.2.
Correct. So what formula are we using? What formula are we using here? What formula are we referring to here? When we have specific heat capacity, I want to calculate for the loss in thermal energy. I have my specific heat capacity is 4.2. My change in temperature is 22.
Mass.
My mass is
Mass was
200 grams.
Yeah.
Yes, teacher.
200 grams of water. So, what formula am I using?
Times specific heat capacity.
everything times each other.
Q equals to mc theta. Theta being the change in temperature. We use big T because small t is time. So for temperature is big T. Theta is change in temperature. So 200 times 4.2 times 22, what do I get?
18000 joules.
18000.
So many zero.
What's my unit?
Joules.
Joules and
Okay. Okay, back to the question.
Yeah, isn't it 18,480?
Let's see, 200 times 4.2 times 22. Yes, correct. 18,480. Sorry, I was looking at the marking scheme. So the marking scheme, right? Okay. The answers are always rounded off. Okay, but I want you to give me exact values. Okay, 80,480. Okay, next. Assume that all the thermal energy lost by the water originally in the beaker is transferred to the ice. Okay, so whatever energy that was lost by the water because it was cooling down, now it has been transferred to the ice. Calculate the specific latent heat of fusion of ice. What is the formula for latent heat of fusion?
Wait.
Is supplied
Q
by
equal to ml.
Right. Q equals to ml. Okay, L being the specific latent heat, Q is this one. So we want to find latent heat of ice. So because, why do I use the water? Why do I use the thermal energy of water and put it when I want to calculate for ice?
But because when ice melts,
Oh, yeah, okay.
Oh, well, technically, yeah, but what is the concept there? Ice is melting in the water, so what is happening?
A reaction.
No, look at the question.
Melting reaction.
what?
The thermal energy lost by the water is transferred to the ice. That's why we're using the thermal energy from the water to calculate the fusion of ice because they are transferred one. Okay? And then mass. What is the mass of ice that was used?
200.
No, that is water.
60, yeah.
And then latent heat is L. That's what we want to find. So 18480 divide by 60, what do I get? What do I get? 18480 divide 60?
08.
Huh?
308.
308. This is joule, this is gram, so joule per gram. That's my specific latent heat of fusion of ice. Okay?
Yes.
Okay. Suggest a reason for an inaccuracy in the value of specific latent heat of fusion of ice calculated in B. So there is an inaccuracy in the value. Assume the temperature readings and the values for the mass of water and all that was accurate. So assuming that when I read the temperature and I used the thermometer properly, I calculated the mass of the water and ice out correctly. But why will there be an inaccuracy in the value?
Human error.
Sorry?
Uh,
So my value,
my-
when I'm looking at B, I have specific latent heat of fusion of ice. Okay? The specific latent fusion of ice, I have mass, but mass they say they have calculated correctly. And then I have my thermal energy. So there is a possibility that there's an inaccuracy here. What do you think will cause the thermal energy calculated to have an inaccuracy?
The energy can be transferred.
Sorry?
The energy can be transferred or something.
So in this case, imagine now you have a beaker of water and you put ice. Now there is surrounding temperature around it. when we measure the temperature of the water and the ice and all that, it's just we are reading the temperature of it, but the thing is that there are surrounding temperatures, so there's surrounding heat transfer. So which means, right, let's say 60 grams of ice was used to cool down the water, yes, but was it just the ice that cooled down the water? There's a high possibility where the surrounding air also helped to cool down the water, because if you have a warm water, if you put it, even if you don't put ice, if you put it in the surroundings, after a while it will cool down because the heat is being released to the air. So there is a possibility that yes, it's 60 grams of ice, but we must take into account that there was surrounding transfer of energy as well, which is what would have caused the reading here to be inaccurate. Okay, so the question says, suggest a reason for inaccuracy in the value of specific latent heat equation. So you can say transfer of energy from the surrounding into the water. Okay, anyone has any questions?
No, sure.
All okay?
Yeah.
Okay, then y'all can take a short break. It's almost 9:55. You can come back at 10:05. Okay?
Okay.
Ataku, are you back?
Back, Cha.
Tachu? Hello?
Yes, sir.
Ngen?
Yes, sure.
Vicky? She's not back yet. Okay. Lohindra?
Yeah, sir.
Okay. So we'll do another paper, some questions as well. Have you all done this paper? Have you all done this yet? Can you see my screen?
Yes.
Have you done this before?
I don't
Check.
think so.
No, I don't think so.
No? Sanoa?
No, true.
No.
Okay. Okay.
Hello.
Let's try this. Okay?
Okay.
Just give me a moment.
Shalok. Shalok.
What lah?
Do we have business today?
Why ask me? I'm not a teacher also.
Student, right?
Okay. Let me share my screen. Okay, y'all can start. And then I'll continue scrolling lah. Okay, so y'all can start doing first.
Check it, scroll down to B actually. And you check.
I will also put this on WhatsApp. So if you all are like faster as well, then you can also refer to your WhatsApp. Okay.
Okay.
Just give me a moment. Okay, I have sent it to the WhatsApp group as well. So you
Okay,
all
teacher.
will look there. I will also post it up here.
Okay.
Teacher, do until where?
Okay, so have you all done A and B? Done A and B, yeah.
B not yet.
Done with A, not B.
Do A and B first. Okay, can I have a show of hands of those who are still doing A and B? Now I'll scroll down to C. Scroll down then. This is C. Okay, can I have a show of hands of those who are still doing? Okay, then we shall discuss. Okay, I have figure 1, distance over time graph. Okay, distance time graph, what will the gradient be for a distance time graph? Are you all there?
Yes, teacher.
For speed time, the gradient is less acceleration. For distance time, what is the gradient? When I take distance divide time, what do I get?
Speed.
Speed. So the gradient of a distance time graph is the speed. Gradient simply means I take the y-axis divide by the x-axis value. So for speed time graph, speed divide time is acceleration. That's why the gradient is acceleration. Okay, so for figure 1.1, draw graphs for the object that is moving with constant speed. Label the graph A. So if constant speed, the gradient will be?
Straight line.
It will be constant line, it will be the same. So, which means the graph will be a straight line. Okay? So you'll have a graph that looks something like this. Okay? And you label this, it says label the graph A. So you label it A. Moving with decreasing speed. What would that mean? Decreasing speed means the gradient is lower.
Lower.
How would the graph be?
It curves to the right.
Okay, you want to draw? Can you draw on my screen?
You're moving at constant speed, not straight line, man, from the distance there.
Is it like this?
That one means you mean like a horizontal line.
Yeah, like a straight line, like from left to right. Isn't that moving at constant speed?
No, with a straight line, the speed is, the gradient is 0. It's not changing because the distance is the same throughout. If I have a graph like this, you're talking about this, right? If I have a graph like this, right?
Yeah.
This one means as the time increases, the distance is still the same. If the distance is still the same, that means the car is not moving. Does that make sense?
Oh, yeah.
Okay. Yeah, so that is B, correct? Nicholas, you have to label the graph B. Okay, so that is for A and B, graph A and B. Okay, so let's look at part B now. Part B. I have a speed time graph. So speed time graph, what is the gradient?
Same.
Sorry?
Gradient.
Why do up? Speed you up by time.
Yeah, what do you get?
Distance, speed times time.
What is speed divide time?
Acceleration.
Acceleration.
Ah,
Gradient for a speed time graph is acceleration. So number 1, moving with constant acceleration is similar to just now. I have a straight line going up. Okay. Now, shall look for this one. Okay, if they ask you to, if you have a straight line, then the speed is constant. Because as time increases, the speed is still the same. That is called constant speed for speed time graph, which means the acceleration will be 0. It's not accelerating. the speed is constant. Acceleration 0 because the gradient is 0. Because when I have a straight line graph like this, okay, this is a speed time, right? Let's have a straight line like that. That means the speed is constant over time. So 10 seconds, 20 seconds, 30 seconds, speed is the same. So constant speed. But the acceleration will be 0 because it's not going faster. It's just same speed. So, which is correct because gradient, there's no gradient. Gradient is 0. So that's why it is such lah. Okay. So the first one, move with constant acceleration will be like this lah. The gradient is the same throughout. So this is A. And then B, moving with increasing acceleration. How would that look like? Sorry, this is label S. Let's label the graph S.
Is it like curve up?
Okay, try and see. Yes? Correct. And then you label that T.
Quite thick, right? This line.
So that will be increasing acceleration. So here is less steep. Remember just now we talked about less steep and then it becomes very steep. So acceleration is increasing. That means the gradient is larger, it's getting larger. Okay, let's move on to the next one. A plane is at rest on an airport runway. So plane at rest means, that means 0 meter per second. No speed, no acceleration, nothing, at rest. Okay. The brakes of the plane are released and the engine provides a constant accelerating force. So acceleration is using the following data. Okay, using the following data, calculate the takeoff speed of the plane. Ignore resistive force. So I want to find out the takeoff speed of the plane. So what do y'all get?
Teacher, I don't know how to do it.
Okay. How about the rest?
Is it 56,000 plus 16,000, then the answer divided by 16?
What do you get?
Wait, I did some calculator. $4,500.
No, not quite. Anyone else has any idea? I'm given the forward force, I'm given the mass of the plane, which is 16,000. And then I'm also given time is 16 seconds. Time of travel along runway. Because after that, why they give a long runway? Because after that the plane will take off and they want to find the takeoff speed.
Should I say 2,500?
No. Okay, let's see. Okay, I've written the thing here. So now, I have force, I have mass, and then I want to calculate speed. So, my forward force is 56,000. Okay. Is there a formula that relates force to mass and acceleration? I have force, I have mass. I want to look for speed. And we know that speed is equals to distance over time. Okay, and then we also have acceleration is change in speed over time. We know that at the start, the aeroplane is at rest. So my initial speed is 0. So force equals to, how do I calculate for force? Force is equal to mass times acceleration, correct? Do you all know this formula?
Yes.
Yes.
That's true.
Okay. So, force equals to mass times acceleration, and force is equals to 56,000. Mass is 16,000. What is my acceleration?
Uh,
3.5.
3.5.
5 meters per second.
okay.
Okay. Now, the question is, we'll go back to the question now. The question is that the plane is at rest, and then the brakes, and then it takes off. Okay, and then there's a constant accelerating force. So now we have found out that the acceleration is 3.5. We have calculated. Okay. Now we know that acceleration is final speed minus initial speed over time. Correct?
Yes.
So I have acceleration is equals to final speed minus initial speed. Initial speed is 0 because the plane is at rest over time travel is 16 seconds. Okay. My acceleration is 3.5. So what is my final speed? That means my takeoff speed lah. From rest to takeoff, what is the final speed? So in this case, the rest is the initial speed. Takeoff,
56.
what did I get?
56.
It's 0.
It's 3.5 times 16, which is 56 meters per second. Okay? Can you understand?
Okay.
Okay.
Yes.
Okay, everyone got that?
Yes.
Yes.
Okay. That is my speed. Try this. Number 2.
Teacher can scroll down. Okay, thank you, teacher.
Okay, those who are still doing, raise your hand. If not, I will scroll down to the next part. Okay, I'm scrolling down now. Okay, this one.
Sure, Nick disconnect already.
Yeah, not sure why.
He
Okay.
say he said got the Wi-Fi people came to his house, so he need to off the modem or
Oh, okay. Thanks. I'll give you all a couple more minutes and then we'll discuss. Okay, come. Let's have a look. Okay. Anyone still not done? Please raise your hand. I'll give you all some time. Okay, let's see. Explain why momentum is a vector quantity. Why? Why is momentum a vector?
Because momentum has no direction.
Got
Wait.
no direction?
Its magnitude and the direction.
Okay. So momentum is a vector quantity because it has magnitude and direction. Okay. Momentum is mass times volume, mass times velocity, and velocity has direction. So momentum has direction. Okay.
Okay.
Okay. Let's look at the second one. The crumple zone at the front of a car is designed to collapse during a collision. So this is how they test cars. Okay, they want to see if it's safe to drive, the impact, and all that kind of stuff. So this is how they test it. So in a test, the car of mass 1,200 kg driven into a concrete wall. A video recording on the test shows that the car is brought to rest in 0.36 seconds when it collides with the wall. The speed of the car before the collision is 7.5 meters per second. Okay, calculate the change of momentum. So let's write down what we know first. Okay, so what are the information that we have?
The mass of the car is 1,200 kg.
Okay. I'm gonna switch this to the whiteboard again. So the mass of car is 1,200. Is it 1,200?
Yes, teacher.
Okay, what else do we know?
It rests for 0.36 seconds.
So sorry, what is 0.36 seconds?
It rests.
As in after it collided?
Yeah.
So after collision, time is 0.36 seconds. Okay, what else?
The speed after collision is
Sorry?
speed after collision.
Okay. After collision is how much?
7.5 meters per second.
1.5?
7.5.
Do we know anything else? Okay, let's look at the question again. Okay, so it says change of momentum. How do we calculate momentum?
Mass times.
Mass times? Mass times,
Mass over velocity.
mass times velocity.
Yeah.
Okay. So they want to look for change in momentum. Change in momentum means what must I do?
Divide.
Momentum is mass times velocity. Change in momentum, what does change mean? What must I do if I want to look for change? Anyone?
I don't know.
No, change in momentum just basically means momentum after collision minus momentum before collision. Let's to find my change lah. Not what am I looking for, or what change am I looking for. So momentum after collision minus momentum before collision. Okay, and we know that momentum is mass times velocity. Minus mass times velocity. Now, momentum after collision. What is the mass of the car on the wall?
1,000 of the wall.
The wall, did they give a mass? No.
No.
Okay. What is my velocity after it hits
I don't know. Before only know. Oh,
Please. No, that's rest. 7 point.
is it 7.5?
The speed of the car before collision is 7.5. After it hits the car, after it hits the wall, what happens? The car is less. It means what happens to the car? Is it still moving after it hits?
0. 0.
0. Minus the mass is 1200. What is the speed before collision?
7.5.
1.5.
1.5.
So 0 minus 0, just leave it up. Minus 1200 times 7.5,
1000.
9000. Mass times velocity. Mass is kg.
Picked up.
Okay?
Okay.
Okay.
Can you understand or not?
Yes.
Yes, sir.
Okay. Okay. I'll give you all some time to copy.
Done, Joe.
Okay, can I change?
And
Yeah, sir.
Let's look at the next one. So the average force acting on the car. Average force acting on the car. Now, force equals to mass times acceleration, correct?
yes.
Yeah.
So that is the formula that we can use. So we know what the mass is, but we need to find out what is the acceleration. So acceleration, how do we calculate acceleration?
Last time I spoke.
V minus
V minus U over T. What is the final speed?
7.5.
0.
0. After collision, it will stop. Initial before collision,
0.5.
7.5. Time?
0.36.
0.36. So what do I get? What's my acceleration?
Negative 2.08.
Negative
I don't know.
2.08. Are you sure? Calculate again. 7.5 divide 0.36.
Oh, negative 20.8.
Negative 20.8 meters per second square. Then I just plug it into F equals to MA. Mass is
1200. 1200 times negative 20.8.
in this case, I don't have to put negative because of course you don't need the direction. So what do I get?
24960.
24960 Force is in?
Newton. Newton.
Okay. Can you understand?
Yes.
Yes, sir.
Yes, teacher.
Okay, I'll give you all a bit of time to copy.
Teacher,
Yes.
if we do it with the negative, will our answer will be wrong?
S times acceleration. Yes, because for force you don't have negatives in this. Maybe it won't be wrong. I just cut off.
Okay. Five more minutes.
Because negative acceleration is deceleration, but when we put it into here, it doesn't matter deceleration or acceleration. So you take off the negative because you calculate the force.
Yeah, understand.
Unless they ask you, okay, is the force acting forward or backwards? Then because it's a negative, then it's backwards, for example.
Okay.
Okay. Okay. Let's go to the last part of the question. If car mass 1,500 collides with the same wall. Okay, so now the car is 1,500, collides with the same wall. All the energy transferred during collision is absorbed by the crumple zone. So now we're looking at energy. Energy absorbed is 4.3 times 10 to the power of 5. So show that the speed of the car before collision is 24. The same speed of car before collision is 24. Okay. So now, before it collides, the car is moving. When the car is moving, what energy is it? What type of energy?
Kinetic energy.
What is the formula for kinetic energy?
Kinetic energy.
What kinetic energy are the formula?
E times M times G.
We'll learn later on, but I did mention it before in one of the revision classes. Half mv squared.
Oh my god.
Okay.
Oh my god.
Yep, you did mention it.
Times 10 to the power of 5. Half. What is the mass of the car?
1,500.
1,500.
500. And then I need to show that the speed is 24. So I calculate for speed now. So 4.3 times 10 to the power of 5. Divide 1,500. Divide half, so times 2. And then v squared is then the square root of this will give me v. So square root and see, do you get 24? Take 2 times 4.3 times 10 to the power of 5, divide 1,500, and then you square root the answer. What do you all get?
Cannot yet do.
Huh?
I haven't do yet.
23.9.
Yeah, so you get approximately 23.9, which is 24 lah, essentially. 23.94, which is approximately 24 meters per second. Okay?
Yes.
Okay, let's look at the last question of D-Day. Okay, so suggest what would happen to the car if it is traveling faster than 24. So in this case, the car, it hits, and then after that, the front part of the car is crumpled. So if let's say it's faster than 24, and that is at 24. If it's faster than 24, what will happen to the car? Sorry?
The driver will die also.
More
Okay,
damage.
explode.
basically more damage lah. Maybe other parts of the car will deform. Basically just more damage lah. In this
Driver
case, you don't say driver die. Well, of course the driver will die, but in this case, it is what will happen to the car. So you talk about the car lah. So you can see the other part. So now if it's just the front part, maybe if it's
You'll
more-
crush until the middle part also.
yeah, the middle part, other parts, will bend and all that kind of stuff lah. So basically more damage lah. Okay? Okay, that is all for today, and I will see y'all next week. Okay?
Okay, sure.
Yeah.
Bye,
Bye.
Cha.
Just take care.
Bye.
Thank you, Cha. Bye, Cha.
Thank you, Bye.